Hi, I'm Pat Kelly. Okay, we actually have a leg up on the start of this problem because they give us a model, they give us the differential equation, and they give us the general solution. Our task is to use the initial conditions to come up with y as a function of t. In other words, to solve the differential equation. When we're done, we're also supposed to graph with a graphing utility, so we'll take a look at that as well. Okay, to begin, I have the general solution. And when we're trying to find the particular solution, we just look to plug in those specific information they give us from the initial conditions. So we have 1, 2 initial conditions. And that's good because I actually have two things I need to figure out, the k and the c. So we'll just take one at a time. I'll grab the first initial condition. That's when they tell me that t equals 0 and y equals 45. What I want to do with that information then is plug it into the general solution that they gave us. So y equals minus 1 divided by k t plus c. And as we've done before, we're plugging in the specific value, in this case 0 for t. We'll plug it in there. And plugging in the specific value of 45 for y, we'll plug that in right there. 45 equals minus 1 divided by k times 0 plus c. Now we simplify this and you'll see that we'll be able to solve for one of our unknowns, in this case c. 45 equals minus 1 over k times 0 is 0, so just c in the denominator. And then I can solve for c pretty quickly by reciprocating. There's also the negative. So negative 1 over 45. So we have our value for c from our first initial condition. Now we'll go to our second initial condition and figure out that value for k, that unknown. So I'm going to come back to my general solution. I'm going to move on to my second initial condition given to me. But I start with the general solution, again, of y equals minus 1 over k times t plus c. But we've solved for c. We know that it's equal to minus 1/45. Now I use the specific y equals and t equals that they gave me in number 2. The second initial condition, t equals 2. Y equals 4, and I'm just plugging those in here and here. My y is 4 equals minus 1 divided by k times my value for t is 2, subtract 1 over 45. Now I just have to do some algebra. And I'm trying to solve for k. I think my first algebraic step here would be to multiply that denominator over to the left-hand side of the equal sign. So I would have the 2k times 4. And I'd also have a minus the 4 times the 1 over 45 to equal minus 1. Trying to solve for k. So now I'll add the 4/45 over to the right. If I add 4/45, I have a negative 1 over there. If it helps, see that as negative 45 over 45, and we're adding 4 over 45. So this equals minus 41 over 45. Solving for k, I'll just do one more algebraic step of dividing by 8. So when I divide it by 8, I get minus 41 over. And my 8 times 45, grab a calculator if we want. I'm actually even thinking that that's 2 times 4, so 2 times the 45 is 90, and then 4 times the 90 is 360. We can grab a calculator if we need to. That's my value for k. So I take these two unknowns originally and put them into my general solution now that we know the specific values. So my y equals, from my general solution, minus 1 divided by My k is this negative 41/360th times the t, plus c, which is the minus 1/45. Okay, so that gives us a particular solution to this differential equation like we wanted, but then they had also asked us to put that into a graphing utility and see what it looks like. So it's a little bit sloppy to put it into the utility like that. So let me come over here and just take a quick algebraic step to clean it up. I'm going to rewrite it exactly as it is over there. Okay, and the one quick algebraic step here then is to clear the fraction of fractions, we'll multiply by the LCD, which is 360 in this case, both top and bottom. But I'm also going to take the liberty to multiply by a negative 360 in order to clear each of these minus signs. If I do that multiplication, y equals 360 divided by positive 41t plus 8. Y equals, and that's a better looking final answer. And with that expression, I feel confident that you could put it in the graphing calculator and take a look and see what it looks like. Okay? Thanks. Hope that helped.